Welcome to Pulse Impressors, where critical care becomes crystal clear. The Impella is a percutaneous, catheter-based pump designed to temporarily replace left ventricular function. It sits across the aortic valve. The inlet draws blood from the left ventricular cavity, and the outlet returns it to the ascending aorta. Left-sided Impella devices, such as the Impella 2.5, CP, 5.0, and 5.5, differ mainly in their insertion approach and flow capacity, ranging from 2.5 to 5.5 liters per minute, each designed to unload the left ventricle, support cardiac output, and maintain systemic perfusion in varying severities of cardiogenic shock. Its purpose is to unload the failing ventricle, maintain forward flow, and stabilize mean arterial pressure. In critical care, it's not a cure, it's a bridge to recovery, decision, or transplant, depending on how the patient responds. Cardiogenic shock is a downward spiral of falling contractility and perfusion. As the left ventricle weakens, cardiac output and cardiac index drop. Pressure builds up in the left atrium and pulmonary veins, causing congestion and edema. As output falls, oxygen delivery to the tissues drops. We see rising lactate and falling urine output. The Impella breaks this cycle mechanically. By siphoning blood directly out of the left ventricle, it reduces wall stress and oxygen demand, while sustaining aortic flow and perfusion pressure. This mechanical unloading is what gives the myocardium a chance to recover. The Impella should be considered when standard measures, fluids, inotropes, and revascularization, fail to restore perfusion. The Society for Cardiovascular Angiography and Interventions, or SCAI, defines stage C and D shock as sustained hypotension and end-organ hypoperfusion despite maximal therapy. When your MAP is below 65, cardiac index below 2.2, pulmonary catheter wedge pressure above 18, and mixed venous under 60%, the left ventricle is no longer maintaining forward flow. That's your Impella window. You can't safely place an Impella if there's an obstruction or lesion that prevents blood flow through the aortic valve. A left ventricular thrombus can embolize when the pump starts. A mechanical or heavily calcified aortic valve cannot be crossed. In severe aortic regurgitation, the device actually worsens regurgitant flow, cycling blood backward. And of course, the patient must tolerate anticoagulation. Without it, the risk of thrombosis skyrockets. Positioning is everything. The Impella's inlet must sit freely in the left ventricular cavity, not against the mitral apparatus, and its outlet should project above the aortic valve. The console displays real-time flow, purge pressure, and motor current. When you hear a suction alarm, that's the device telling you the ventricle is underfilled or the catheter has shifted. It's a physiologic problem, not a mechanical one. Cardiac output is the volume of blood pumped per minute, and cardiac index adjusts that flow for body size. The Fick equation uses oxygen consumption to calculate true flow. It's most reliable when thermodilution fails, like with tricuspid regurgitation or ECMO. The cardiac index tells us whether the heart is delivering enough blood relative to demand. We aim for 2.2 or higher. Oxygen delivery, or DO2, integrates both flow and oxygen content, a key marker of whether the patient is adequately perfused. Cardiac power output, or CPO, measures how much hydraulic energy the heart produces per second. It combines mean arterial pressure and cardiac output. In essence, how hard and how fast the heart pushes blood forward. When CPO drops below 0.6 watts, the ventricle is no longer providing enough energy to sustain organ perfusion. Cardiac power index is the same concept normalized to body size. These are the most reliable single predictors of survival in cardiogenic shock. The left-sided Impella can only pump what the right ventricle delivers. The pulmonary artery pulsatility index, or PAPi, measures right ventricular contractile strength. A value under 1 signals right heart failure. Pulmonary vascular resistance, or PVR, shows how hard the right ventricle must work to push blood into the lungs. High pulmonary vascular resistance means afterload is impeding forward flow. Right ventricular stroke work index combines stroke volume and pressure difference, the right ventricle mechanical work per beat. When PAPi and right ventricular stroke work index are low, and pulmonary vascular resistance is high, a left-sided device alone will fail. You need right ventricular support or vasodilator therapy. Systemic vascular resistance reflects total arterial tone. Too high, and the left ventricle struggles. Too low, and perfusion collapses. Left ventricular stroke work index shows the energy each beat contributes to forward flow. Together, these guide you in balancing device flow with vascular resistance, optimizing perfusion without overloading the left ventricle. Our bedside targets summarize it. MAP greater than or equal to 65. Cardiac index greater than or equal to 2.2. Mixed venous greater than or equal to 60%. Wedge 12 to 18, and lactate trending down. The Impella handles flow. Your drugs fine-tune resistance and contractility. Use Norepinephrine to stabilize MAP without excessive tachycardia. Add Vasopressin if you need more tone without more heart rate. For right-sided support, add Dobutamine for contractility or Milrinone for eye-no-dilator effect. It improves right ventricular ejection and lowers pulmonary vascular resistance. Once perfusion stabilizes, taper pressors before reducing pump speed. The Impella's motor is cooled and protected by a Purge solution that continuously flows through the catheter housing. Normally, this is Heparinized Dextrose, keeping the motor clear of fibrin and thrombus. In patients with heparin-induced thrombocytopenia or bleeding, we switch to a sodium bicarbonate purge. Bicarbonate neutralizes acid buildup inside the pump, preventing protein precipitation and clot formation, without exposing the patient to systemic heparin. If LDH or plasma-free hemoglobin rises, suspect hemolysis. Check position and preload first. When the Impella underperforms, troubleshoot systematically. Start with imaging. Confirm position. Assess volume status. A starved left ventricle will cause suction alarms. If the right ventricle is failing, the left ventricle can't fill, so Impella flow falls. If hemolysis develops, lower pump speed and reposition. Persistent low PAPi, despite optimization, means you need right ventricular support. Don't wait until both ventricles fail. Evidence shows one consistent truth. Early intervention improves outcomes. Trials like Impella safety randomization in shock. Impella 2.5 versus balloon pump reduces mortality in STEMI patients treated with primary PCI in severe cardiogenic shock, also known as IMPRESS, showed rapid hemodynamic improvement, but no survival benefit when used later. Danger shock or Danish-German cardiogenic shock trial changed the narrative. Early Impella CP, before irreversible shock, reduced 6-month mortality. Use structured checkpoints at 2, 6, and 12 hours to trend cardiac index, cardiac power output, mixed venous, and lactate. The data will tell you whether to escalate, maintain, or wean. Weaning should be physiologic, not numeric. Once the heart demonstrates cardiac power output greater than 0.8 and flow or cardiac index equal to or greater than 2.4 with stable oxygen delivery and minimal pressors, you can begin gradual P level reduction. Always recheck echo and lactate. The ventricle must prove it can sustain output before device removal. Verify placement frequently, every shift, document flow, and trend hemodynamics. Ensure you are following your hospital policies and doctor's orders regarding management. Early detection of hemolysis, limb ischemia, or low flow saves limbs and lives. On Doppler, distal pulses with an Impella sound like a continuous low hum, with faint, blunted, or no pulsations, rather than distinct whoosh beats, reflecting the device's near-continuous flow. This checklist is your safeguard. It transforms reactive care into proactive management. These examples show how numbers translate to physiology. In the first, cardiac power output is 0.54, critically low, even if MAP looks decent. The ventricle is generating pressure, but not flow. In the second, PAPi is below 1, confirming right ventricular failure. The left Impella alone can't succeed here. You must fix the right heart. This is Pulse and Pressors, reflecting on the marvels of the human body. Subscribe to learn more.